Hello and good evening, good afternoon, good morning to everybody. Thank you for joining and welcome Veronique to this live Neo4j live session today. Thank you for joining us today. Good afternoon, Veronique.
Hello. Thank
Hello.
you for having me here. And
Thank you.
hello, everyone.
Hello, everybody. Exactly. Let us know where you're watching this from. If you want in chat, it's always nice to see our international audience. Like I said, today I have a special guest, Veronique, in this Neo4j live session. On the title is a little bit long. I mean, we had to narrow it down a little bit, but it's still the full title was even longer. But we agreed on calling it Normalized Categorization of Multisource Geolocated Data, and then there were two more lines of of title. So it's
Yeah, I like to talk too much.
it's a long one, but it's nice. I think maybe I'll give a quick intro on Veronique, and then we dive in. So let me quickly switch this over here. So Veronique is actually a community member since a couple of years ago now, and this is a Twin4j featured article from October of 2020. So actually a couple of years ago now. But here you are the featured community member. So if you are, dear community, active in the Neo4j world and you do something nice and do something interesting, let us know. Tweet us or hashtag Neo4j, so we'll discover it, or point us out in Discord or in the community forums, and then you might be able to also become a community member and a feature like this. And here I just read this out what Mark wrote back in the day. Veronique has been playing with computers since the age of 10 and has a background in computational linguistics. And in September 22, Veronique started a one-year mission at the French National Institute of Geographical Information, IGN, where she worked on geolocalized data, ontologies, and labeled property graphs. So that's pretty cool. And I think, I don't know, Veronique, is this actually the project that this other one, I guess it lead into this one from last year, or is this a different project?
No, this is the one. This is the
This is
one.
the one.
I think the article was published because I spoke at Node 2020, and I
Yes.
was just at the time of Node 2020, I was starting this mission I will be talking about today. The mission ended in August 2021.
Oh,
So yeah, this is what it is about.
oh, cool. Yeah, great. So I'll share the link on of your Notes 2020 talk as well, so people can watch that as well. And then, yeah, like you said, I mean, this I discovered last year, and we've also featured this in one of our Twin4j newsletters towards the end of the year. I think, I don't know, November, December or something. And this was your basically, I guess this is the culmination of this whole project, and it looks very interesting, looked very fascinating. And you had yeah, I guess here International Geographic Conference in December. So I guess after that, we must have found this and put it in our Twin4j. And I thought, oh, this is great, this is cool. So hence I reached out to Veronique and asked her, hey, do you have time? Do you want to present this? Do you want to showcase what you did here with your team? And thankfully, Veronique said yes. So I guess, yeah, maybe Veronique, do you want to say a few words about yourself, what you do, and how this project maybe came to be?
Right. Well, this was. I will talk about the project and what I do in a minute. I had a few slides about
Hmm.
this. Maybe I can say a word about me and Neo4j.
Absolutely.
Uh,
Yeah.
I, 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 I first heard of Neo4j, I think, in 2013. I remember going to meetups here in Paris and eating pizza back in 2013,
Where all good
and
things
yeah.
start.
Sorry.
Where all good things
Yeah,
start
with
is
the
with the pizza.
pizza. And I thought, wow, this technology, I mean, this grafting is really something. And so it took me some time. I can't remember, it was maybe even before 2011 or something, because it took me some time. I had other missions, and I only really got seriously in. I was still listening to conferences and things, but I really got into it seriously in 2020. and that's when I got certified, and I did a few projects like that with Neo4j.
Cool. Yeah, that's a long journey, right? I mean, if you started a couple of years ago already, 2013, I think that was very, very early in the day. So you could call yourself an influencer, I guess. So it's early adopter for sure. And it's good to see this project, and I think this is yeah.
I don't know if
Cool.
I'm in influencer, but I had pizzas.
Yeah, well, I guess that's good enough. That's good enough. We have a couple of people joining. So John from the UK, from Luxembourg, Dimitrio. We have somebody from Illinois, USA, Seattle as well. I guess is that early? I think it's early. Yeah. I mean that must be just about the start of the day for Seattle, definitely. And then Sao Paulo, so Brazil. I have no idea what time it is there, but I guess also good morning, I think. Thank you for joining. All right. Shall we dive in? You said you had a couple of slides. Do you wanna kick off with the slides, or how do you want to start?
Yeah, no. Maybe you can run the what I've sent to you, and
Oh, the video. Yeah. Okay. Yeah.
yeah,
Of course. Yeah.
yeah. The presentation I've recorded on a video. So feel free to ask questions and drop remarks. So we can chat in the YouTube chat or wherever you're seeing this. And yeah, and then after the presentation, we can have a quick demo of the script for
Okay.
QGIS.
That sounds good. So I'll play the video. So Veronique has prepared a video, so it's easier. And then we obviously chat is open, so please ask your questions, and we will come back in after the video, and then absolutely have a demo. So I'll switch this on. Give me one more second.
This presentation is about how we build a multi.
Shoop. Okay, I guess I'll do it like this. And
source
go.
graph database with geolocated data and how we categorize the data using an ontology as a structured thesaurus.
Does that work, or is that
Then I will
too
demonstrate
Sounds
low?
a little low
the
for me.
database can be displayed on a map with a
All right,
QGIS
I
Python
think I
script.
cannot. From here, I
You
cannot
can't
make it.
push it further.
To introduce myself, I
This
will
is the
briefly
maximum I
explain what I
can
call
give it.
information design full
Give me,
stack,
Or
which is what
maybe
I do.
we're gonna have to do
Then
it
I'll
on our
present the
side.
use case
Yeah, I
and
can try
explain what
another
the Landmarks
thing.
Objects
Let me
Ontology
see. Is
is.
this audible
We'll
chat
do a very
or
quick
too
reminder of
quiet?
what labeled property graph databases are and the different
Here
formal
it's a bit
ways they
quiet,
offer to categorize
but
information.
I can push my
We'll then talk about the
speakers.
modeling
Oh,
of the
that's
GeoGraph
better.
database, how data has been imported, the rules used to instantiate the Landmarks Objects Ontology with the data will then be presented, as well as a wrap-up of how the graph structure has been used for this work. We'll end with a demo
I
of
think
the
it's a little
QGIS
bit
script
quiet from what
that
I
allows
get.
to
Let me
display
see if I can.
database queries results on a map.
I can make this different.
Information design full stack is the
Although
way
I
I
don't think I can
generally
actually.
describe the different aspects of what I'm doing. It is everything about representation and structure of information. There are three ways of understanding representation. It can be human external, that is a production that represents information, text, image, and different forms of visualizations, databases, etc. A representation can also be human internal.
Yeah, I'll just quickly post this. Unfortunately, I have the same volume on my machine, so I cannot increase it anymore. I think the recording volume was a little bit low. Do you wanna? Because now I think you're better in terms of voice. Do you wanna speak over it while the video runs? Would that be possible?
Yeah. Do you think people? Do you think people won't hear?
Oh, volume level sounds okay for me. Okay. Well, if people seem to be, I just have maybe a different sound. So okay, if that
Yes,
is.
maybe if people can put the speaker a bit higher on their ends.
Okay. Well, then I'll click play, and then maybe I'll mute us too, so we don't interfere. Okay.
the way we represent ourselves information in our mind, which includes questions of interpretation. Finally, it can also designate the process of producing a representation. So information design, full stack, is about representation and also about structure of information. The way I see it, representation is like the puppet and the structure is like the wires and the wooden structure that allows to correctly position the puppet. If they can be studied separately, representation and structure are in fact highly interrelated. What I'm doing is based on human language and formal language studies. I have a specific interest in visual representation of information. I do data analysis and modeling for databases and applications, as well as information architecture for website and my personal information system. Concretely, this means doing programming and script writing, web application creation, data analysis, document structuring, and what we will be talking about today, database structuring. The use case is for a project called Choucas. Choucas is the name of the black bird that you can see here on the logo. If I got it right, the idea is that the bird oversees what happens, like the helicopter that is sent to search for victims in the mountain. So the Choucas project is a research project aimed at exploring solutions to help mountain rescuers localize victims upon emergency calls. The work presented is the result of a one-year mission for this project. Here are some examples of what can be found in the phone conversations between lost persons and mountain rescuers. I took the trail in direction of Oursière waterfall, or left from Bourdoisan on foot on the route to the ski resort. I can see part of a water body. I'm under a 3-strand power line. In order to be able to propose useful information to help localize the victim, the system needs to identify what in the collected data is a trail, a waterfall, etc. An ontology of landmark objects had been built by other Choucas project members. The work presented here uses the ontology as a thesaurus to normalize data categorization imported from different sources. Here is a quick reminder of what the basic elements of a label property graph are. You have nodes. Each node can have one or several labels. Relationships that connect nodes are hard-coded when created in the database, not later computed with joins like in relational databases. Since relationships are hard-coded as pointers, they are very efficient to traverse and to apply all sorts of graph-based algorithms. Both nodes and relationships can have properties, that is, a name and a value. This means if all these nodes represent lakes, you can either put a property named type on each node with the value lake, put a label lake on these nodes, or create a node labeled as a class, give this node a name property with a lake value, and relate it to all nodes representing a lake. This is to keep in mind that identical property values, a set theoretic representation by labels or links to class, are formally equivalent ways of categorizing nodes. Modeling the graph database means to choose which of these technical solutions best meet the different needs for categorization. In this case, to structure geolocalized data that have been imported from different sources, we need to categorize by source, extraction date of the dataset. Nodes in the database also need to be identified by technical purposes. They can be geographical objects, geometries, or other technical nodes for spatial indexing. And as we've seen earlier, the system needs to identify objects according to the Landmarks Objects Ontology. Just to give you an idea of the ontology, here is an excerpt. It's an almost strictly hierarchical structure of classes and subclasses There are a few cycles, but it's mainly hierarchical. The Landmarks Objects Ontology has been imported in the database as nodes, with the class label for classes. Class nodes are interrelated with its subclass of relationships. Preferred label of the class are a property of the node, both for French and English, whereas alternative labels are node attached to the class because they can be none or several. As you may know, the good thing with a graph database is that you don't have to finally determine a schema before starting to import. You can make a first model hypothesis, start import some source, and adjust the model according to what you actually find in the data. For example, property names have been harmonized along the way. We first came up with a schema for simple objects, that is a node with a geographical object label for the object and its attributes as properties. The spatial plugin developed by Craig Taverner is used to deal with geometries. The plugin builds nodes for geometries. It could have been possible to put attributes and geometries on just one node, but separating them makes things easier if for some reason we have to clean out geometries without impacting other data imported for the objects. At first, we thought toponyms could be modeled the same way with a toponym label, but my geomatician colleague said toponyms are geographical objects, so we also added that label on toponyms node. A lot of discussion went on with my geomatician colleagues about what geographical objects and landmarks are compared to toponyms. Modeling of the database has accordingly been iteratively adjusted. This is the current state that can still be discussed. What we have are landmarks and toponyms connected to a node for the geometry. Toponyms can have several nimes attached. And when possible, toponyms are linked to the corresponding landmark object. We've just seen the schema for landmark objects and toponyms. This is an instance. Here is a landmark object that is a polygon. And here is the toponym that is a point by definition and is associated with different possible names. The two nodes are related by link is_toponym_r. Nodes for geometries are related to technical nodes created by the spatial plugin to deal with spatial indexing. The spatial plugin allows for simple spatial functions like intersect to be run in the database at query time or to compute new information. Data have been imported by source layer. Here are some BATI layers from the French National Mapping Agency database BDTopo, with, for example, the layer for electric pylons. Here are the attributes that can be found in the shapefile. As we've seen, this is the structure for a simple object. When I started importing data, shapefile import with the plugin triggered an error that I couldn't figure out, so I switched to CSV and stayed so. Also, some spatial reference system conversion is needed because the latitude-longitude coordinate system Neo4j uses is SRID 4326. Conversion is done during the QGIS export with a couple of clicks. Then importing the data is simply about creating the geometry node with the plugin here, and attach the yield node to a newly created node with any selected attributes as node properties. Creation date time and creation type properties are added for trackability. Because some layers had a lot of properties, I wrote a QGIS script that automatically generated this cipher-like list of properties, so I did not have to type them all, but just commented those I thought would not be useful. Since for trackability, the import file name is inserted as a property, I put the import file name as a parameter of the script. This is a little trick so I don't mess up when I use a new version of the imported file and want to reuse the import script. putting the import file name as a parameter makes sure the actual used file and the property value are consistent. Here is an overview of the schema for the database to give you an idea of the volume of data. We have 1200 nodes for categorization, almost 280,000 geographical objects, and about 290,000 technical nodes. If we now look more in details into nodes with a geographical object label, since on each node we can have several labels, it's been used to identify and easily extract information by different sets of categories. So these nodes also have a toponym or a landmark label. Since we started importing data extracted in 2018 and then imported recently extracted data, nodes also have a version label. This way, it's very easy to deal with data from a specific extraction date. Here, for example, is the command to delete all 2018 data. There is a set of labels for each source, and even for each layer of the main source, so that information in a node can easily be traced back to its origin. Also, we've added a label computed with the plugin by Intersect. It allows to easily make test queries on objects that are within a limited study zone. This last command returns objects from the 2020 extraction of the Chem2Chem source that are located in the limited study zone. Import of the Landmarks Objects Ontology is done with the JSON version of the ontology. As previously said, preferred labels are set as class node properties. And for each alternate label, another node is created and attached to the class. Those of you who know Neosemantic, the plugin designed to deal with ontologies, might wonder why I didn't use it. There are two reasons. One is that when I started this, I knew next to nothing about RDF and semantic wet formats, so I wanted to get my hands into it as a way to figure it out. Second reason is that the point in using ontology format and technologies is to be able to automatically infer information. There is nothing like that in the landmark object ontology that is used here. It has been designed as an overview of the terms used in the domain. The way I see it, it's more of a structured thesaurus than an ontology. Also, I noticed some formal issues in the file, and I worried they would make my life difficult if I would use standard tools that expect strictly well-formed files. Therefore, I decided writing the code to import and also to export the ontology was probably the best trade-off. After importing the Landmarks Objects Ontology and geographical objects as nodes, with a source information for categorization in a property named type, the instantiation process consists in relating objects to the corresponding class. This is done by a set of rules. First, for some layers labels that actually are object categories like pylon, the object is simply attached to the corresponding class. Then, if the string of the category in the source is identical to a class preferred label, the object is also attached to the class. Another rule applies if the string of the category in the source is identical to a class alternate label. Then the object is attached to the class, and a relationship is also created between the object and the alternate label to trace that the alternate label has been used. This is about using relation transitivity to normalize categorization. The same principle is used for variant spellings and some plural forms that were found in the source. For example, this is how the type rocks with an S we'll still attach the object to the rock class. In the imported data, we found some objects with an empty type, but with a first word in the name that clearly indicates the category, like source. If we systematically use the first word to categorize the objects, we produce wrong connections, because, for example, we can have something called Cascade de la Pisse, that is the name of a waterfall, but it's also used to name the car park. Side note, yes, Pisse does mean the same in French that it does in English, with the same language register. This probably just illustrates the poetic spirits of maintainers when they name waterfall. Well, in any case, we figured that applying the rule on first word only to a subdomain avoids wrong instantiations. So we first extract the list of classes that are subclasses of the hydrographic class. We can even add classes that are in a different era of the ontology because they are human-built and not natural hydrographic installations. We then limit the application of the rule to objects that come from identified hydrographic source layers. And if the first word of the name of the object matches one of the listed classes, then we instantiate the object to the class. As for instantiation results, there are about 480 classes in the ontology. 150 are instantiated directly with objects. Another 70 are instantiated if you cumulate their children's instantiation. On the almost 280,000 geographical objects, 250 have been attached to a class. Doing a precision recall evaluation did not seem to have much sense because one of the reasons multisource is used in the project is because it is known that some sources are better for certain type of information, other sources for other information. So we had no, so to speak, universal usable reference. So what we did is look into the data manually and via confusion matrix to spot and filter out errors by iteratively adjusting rules. Eventually, the instantiation process, by connecting the landmark object ontology to real-world data, also resulted in bringing out some inconsistency in the ontology, leading to some adjustments of the ontology. Relations and properties created by instantiation rules allow to later analyze what happened during the instantiation process. For example, if the instantiation process used an alt label, a relation is created between the used alt label and the instantiated object. A simple query can show what kind of geometries are found for each category. And if you add this optional match on a related label, you can see which alt label of the ontology are actually used with your data. Sorry, I did not rerun this one with the English labels, but you can see the classes that are not instantiated by alt labels and the used labels. Instantiation rules also add a property with a name for the used rule on the created is instance of relation. So a very simple query can show which rule has been used and how many times. Mostly used rules are the one on the label and the ones with the type and either the preferred or the alternate label. The rule on first word helped categorize a couple thousand untyped objects. Some test relationships between objects, like is close to or is same as, have been put into the database. Unfortunately, this aspect, though it was the initial idea, has not been taken very far, among other reasons because of the difficulty to formally define what a rule is. The idea was, if the victim says, I'm on a route to Sape waterfall and I passed a mountain pass, what we're looking for is a route here that is connected to both an object node with is close to relationship this object node being related to the mountain pass class, and the root node being also related to another object node with SAPE in its name and instantiated to the waterfall class. So let's wrap up the different ways the graph structure of the database is used. As just mentioned, the initial idea for using a graph database was to import spatial relationships between objects. This is still to further implement with more relationships. But the graph structure is useful in several other ways. Technically, the schema can easily be adjusted, and not one table projection is privileged by construction. So for data analysis, the graph can be projected in as many tables as you need for different purposes. We'll see more examples in a minute. A subgraph can be used as search pattern. The granularity of a selection, a whole table or just a few objects, is easily adaptable. The graph structure of the database is also used for instantiation process. As we've seen, relation transitivity is used to normalize categorization through different alternative labels. The graph structure is also used to apply some rules only to a subdomain of the ontology. Before we move on to the demo, let me give you a few examples of why I found the graph structure of the database very helpful for data analysis. We had different sources structured in tables, an important source of the project being the French National Mapping Agency, IGN BD Topo, which is structured in over 50 layers, that is as many tables grouped by theme. Some layers contain potentially very interesting fine-tuned information. Here you can see root chunks labeled as staircase, path, etc., or different kinds of forest, deciduous, coniferous, that victims may recognize and mention as a localization clue. So at the beginning of the project, before this work on graph database began, researchers had to manually go through all the layers to pick interesting items. With a graph database, you can just put everything in. As we've already seen, you can adjust the schema along the way. And after the normalized categorization is done, you can easily explore all you have with some simple cipher queries. For example, in which layers do we have lakes? Here is the query. And BIM, here are the layers that contain lakes, instead of picking them manually. How many objects in the hydrographic subdomain? We can use the query we've seen before to list classes that are subclasses of hydrography, and then count objects attached to them. And by just changing the name of the root class in the query, we can do the same for another subdomain. Here is how to list types in a specific source that have not been attached to a class of the ontology. This is it for the presentation. Here are some references to find out more about the project, the GeoGraph database, and related work.
Super. That was cool. Thank you, Veronique from yesterday, for presenting this.
Yeah, I love to speak, as I said, so I can. Usually, I can. If people ask questions, I like to speak in the chat at the same time when I speak in the video.
Yeah, no, that was cool. If you have questions in chat, please do let us know. In the meanwhile, I have two questions I can quickly ask you before we maybe jump into the demo. One is maybe showing my ignorance a little bit, but this thing you're doing, is this then used to create maps for other people, or what is the main kind of use case of this graph database you have created? What is the who is basically, what I'm saying is, who is using it, and what, I mean, you showed a couple of questions. Who is the benefit?
Well, the use case is the research project about mountain rescuer who need to localize victim. You know, they have emergency calls, and so according to what the person says, there were a few examples at the beginning. I left from Bourdoisan. I passed a mountain place, etc. And so from these clues, the rescuers need to localize the victim. And so the different aspects of the project were about how can we help, how can we provide information to the rescuers so that they more easily and as quick as possible locate the person. So the idea here is to put the data that so it's a research project. It was about exploring ideas, and here the idea is to have all sorts of information. As I mentioned, we have a very important source, which is the National Mapping Agency reference map. But some information, like for example, refuge. I can't think of the English word. You know, these places where
Shelter.
shelter, yeah, where people go after they go they go for a walk, and some kinds of information can be more precise in crowdsourced website where people describe the trail they took to go to that cascade, to that waterfall, or that kind of. So the idea was to get information wherever we could find them and put them in this database, and then well, make it available, make them available to the rescuers.
Ah, okay, cool. Yeah, that's especially I can imagine in mountainous areas, like you said. I mean, if you go hiking or if there's something and then you you get lost or something and then something happens, an accident, and then you call and say, I actually I don't know where I am. Google Maps does not work. So I mean,
Yeah,
yeah,
this is the use case, because
yeah,
when people have their mobile, the rescuer can just send a text that basically
yeah,
geolocates the. But sometimes people, well, the battery is out, or I mean, there are cases where these techniques cannot work, and sometimes it's the worst situation where people fell and have
yeah.
an injury. So they need to be very quick at this time.
I can imagine. Yeah, that's correct. Okay, shall we go into the demo, Veronique?
You're even better than me, because you actually talk and type in the chat at the same time. It's not a video. I mean,
Yeah.
I'm impressed. Yes, let's go ahead for the demo. Let me just organize myself. Here we go. So I need to share my screen as well.
Mhm.
Let's see.
Yeah, while you do that, I have put the link to the GeoGraph project in the chat. So if you want to know more about it, uh, you know, click on that, read more about this. But now, yeah, let's do. Yeah.
Here we are. And so share screen. I want to share which one do I want to share? I want to share this one.
Okay. All right.
Okay. So yes, just yeah. Uh, just to show you that I'm running Neo4j in Windows 10, and this is the community version of the Neo4j desktop. So you need to have the Neo4j instance running with the database active. And here is where's my script? Here is this what the script looks like. I mean, a big disclaimer, this is not a robot script. It's just a tool I wrote for myself in order to get some visual rendering of the content of the database on a map. because since I was building a geolocated a database with geolocated information, I couldn't think of not being able to have a spatial display for the content of the database. So it's just a script that you need to manually adjust according to what you want. The idea is that I wrote generic cipher queries with parameters that you can adjust, and the script generates a point, a line, and a polygon layers, which are the typical, which is the typical way of doing things in spatial, in geomatics. So basically, you have three ways to filter the data. First is you write a regular expression that will apply on a property, typically the name, but it can be type or whatever whatever property you want. The second filter is on the class. You can list one or several classes you want the object to be in. And the third filter is on the label. So the three filters are cumulative, so you can use just one or combine them. And I think I just said the results are displayed by geometry type. You have a layer for points, a layer for lines, and one for polygons. So let's. Right. This is where you adjust the parameter I just mentioned. For the sake of the demo, I prepared a list that I can just copy paste here. Save this. And so here is QGIS. I don't know, I never pronounced it in English. You have the layers. Typically you have layers in geomatics. Data are displayed in layers that are listed here on the left. You have the map, and this is the Python script that we can just run. Oh, it's the old one. Okay, this is the last one I tried before, so I have to. It's a bit long because it was the last one. Sorry about that. Oh, and let me check it. Yes, it should be. Oh, right. No. Well, this is about not being a robot script. You have to deactivate some parameters sometimes before, because there are precedents on the different parameters. So here it should be better now. Bad reflex. I just saved this project and it takes forever. It was not. Yeah, my Control S goes like even at night. I do Control S to save.
Yeah.
Okay, it's done now. Okay, it's done now, and let's rerun it. Okay, so the console here says, sends a reminder of what has been the criteria that are selected and how many objects in each layers. And so the layers appear here. So Vianney is the name of a lake. So let's imagine I'm looking for this lake. I can zoom on the layer, and I see I have object here and object here.
Are the orange dots? Is that
yeah,
what?
the orange dots are the returned objects. And so let's see what this is. Well, this is a church. So all these information are extracted from the database. And so we say this is a church, so this is not what we're looking for. And we can zoom in here. This looks more like a lake. And maybe I can see the attributes, so the attribute table for polygons. And I see, yes, I have a, so you see, you get the main information from the database, that the ontology class, the type, that is the source categorization information, the source, which source the information is in, and the labels that, in this case, for the French BD topo that has, as I said, about 50 layers, the labels here gives information on which label it comes from. There's the label for the version as well. So you can see where the information that is displayed comes from. And so, yes, if we were looking for a lake, I mean, we wouldn't want this church here. So let's just adjust the script accordingly. Yes, I want to enter this. And so I just uncomment this to get the lakes.
Okay. Yep.
And I run this. Let's get rid of it. I do get rid of this. Okay, so I'm taking out the previously returned result, and now I only see 6 points. So you might wonder, why do I have a line here? Well, yeah, we'll see about that for the cascade, but it's probably because of yeah, the hydrographic network is labeled. So every chunk of the hydrographic label has sometimes have a name, and so this one has been named a resource. So it comes out as a line. And what else did I want to show you about this? So here we have the lakes, and basically it's all the same lakes, but from the different sources.
So this is the same lake, right?
Yes,
Yes.
it's different version of data, because here I still have I used data exported from these. These are what's the word? WhatsApp, where people crowdsourcing website, and so an extraction has been made in 2018, and these are more recent data. So, I mean, we could get rid of some of it. It was research. It was just about getting things together.
Yeah, that's all right. So we looked for a lake, and then we just have a rough idea, and now we found the lake. So we think, okay, this person that needs help is somewhere in this area.
Well, the script is not necessarily the script is not at all meant for the rescuers. The script was meant for me as I was building the database. There is another in the last slide I showed. There's another interface that has been developed during by members of the Choucas project. It's called Gaspar, and this is a real interface that is actually connected to the database, and that interface is meant for the rescuers. this is just if you have a database with geolocated information. Since Neo4j natively only deal with points, if you have geolocated information with WKT and you want to display it, this is a way to do it. But it's a way, as I mentioned, it's a way just for research and test purposes. It's not a proper interface.
Oh, okay. That's good to know. I think that's also what Nat was just pointing out in chat is like, is there
I've lost track of the chat because unlike you, I can't talk
no,
and
yeah,
read.
no
And
worries. It's
okay,
Nat has
if
basically
the
had the
bus,
same
if the,
question that I was having is this then now for the rescue team, or is it, but then you just answered it by
yeah,
saying it's a
okay.
different
No,
tool.
no, no. It was just a solution to get to have a display for geolocated data in a
Okay.
Fuji database.
Okay.
And just maybe what else? Um, yes, just I mean, the last test we can do is the one that run at first to see you have two variables to display classes. You can either have a specific, different a list of class, but then you will have all points in one layer, all lines in one layer, and all polygons in one layer. If you want a layer per class, one layer for the fountain, one for the waterfall, etc., you use this
Okay.
variable, and we can run this one. So I can just okay, there is just here.
When it says points, that's the total hits, right? The total individual points on the map, which fit that description. Is that
In the
it?
console, in the this is the Python console, and right, this is telling you first, well, what is the query, and then how many results you get
Yeah. Okay.
per layer per geographic type.
Okay.
Okay, and yeah, there's a little trick I like to use in QGIS is that you can copy paste the style of what they call symbology in geometric. Quickly, yeah. And so these layers are actually dead. They're empty because they were dynamically generated by the previous instance. So they die when the connection to the database die. But I keep them so I can just reuse them um, for the symbology, because when you have a lot of objects and different
Okay.
on the map, you
Yeah.
need to identify what is
Yeah.
what, right?
Yeah. That's helpful. Yes. So these are now what did we get back? Lakes and
So these were the cascade, and we have yeah. I sort of was too quick earlier when I mentioned the line. The problem of the line was more about this one, because a waterfall, you don't think of a line for a waterfall. I mean, maybe I realize that Neo4j people are not um, geomatic people, so maybe they're not. It wouldn't strike people as it would strike a geomatician, but this is a bit weird to have a cascade as a line. But the thing is, it's as I said, the hydrographic network is cut into chunks, and each chunk can have a name. So the chunk where very likely the cascade is, the chunk of the river where the cascade is tagged as a cascade.
Okay. Okay.
Okay, well, I think it's really just a tool for dev purposes and test purposes, and so yeah, I think this is maybe about it.
Cool. Thank you very much.
Thank
Thank
you
you very
for
much,
your
Veronique.
attention.
Adam thinks those are very hairy
This presentation is
regex.
about how we built a
I wanted to.
Oops, the video. Yeah.
No, I wanted to jump here to your very last. Here you go.
Well, they're not that. Oh yes, you took the. It's just about having the beginning of right. Yeah, it's just the Harry. I never heard of that phrase, but it's just that you have a beginning of word and case insensitive. Case insensitive is this, and beginning of word is this, and so apart from that, there's nothing very complicated in the regular expression.
Okay. And then one more question came in from Ted. In this process, what are you importing into Neo4j, or is
So
what is Neo4j's story?
the spatial plugin allows to import shapefile. The thing is, when
Mhm.
I did that, when I tried that, it was triggering an error and I couldn't figure it out. So at the time, I
encountered.
decided, okay, I'm going to convert the shapefile into a CSV because anyway, I had to do some what's the name, some spatial reference system conversion as well. So I
Mhm.
thought I might as well change to CSV, and so in this case I import CSV. But I think by now, I haven't checked lately, but I think by now the problem with importing shapefile with a spatial plugin should be solved. So you could probably import shapefile by now.
Okay. Cool. All right. This was great. Thank you very much, Veronique. I think this was very
Thank you.
insightful, very different topic and very different use case. I think from what we saw in the past. So geospatial is its own is its own world sometimes.
Yes,
Yeah, but it's
it's I'm looking forward for the geomatician and the graph database community to meet because when I had this talk at the geomatician, they were like, "Ooh, what is this graph database thing?" And I'm
yeah.
here, and "Ooh, what is this geomatician thing?" So yeah, eventually they will meet. I hope.
I hope I hope so too. Definitely. Yeah, that sounds like there is need to talk and to discuss things. Um, yeah, with that, thank you very much, Veronique, again for joining me
Thank you,
today.
Alex.
Thank you for taking the time and answering the questions and presenting.
Thank
Thank
you,
you all for
everyone.
watching. Hope you had found this insightful as well. If you I will put in the description, you'll find the links to Veronique's projects and to the research time. So if you want to connect with Veronique, there is a possibility there via Twitter or via other means. Um, if you are, looking for the next stream, then we will be back on Monday, Michael and I, for our next Aura DB session. Until then, thank you for joining. I wish you all the best. Take care and have a good rest of your week. Bye bye.